Hello, we are Team 1 of the third and final project of CIS 181. Our members consist of Kyan Leet, Ian Rodriguez, Tyler Souza, Olu Allo, Jake Tobiasen, Doug Andrade, and Noah Cabral. We made a few modifications to the game, such as the 21 enemies that we created. However, our main modification is the addition of a 2-player co-op. You heard that right, we added multiplayer to this platformer. So to go through a list of a couple of the changes we made, we removed the majority of the code reflection code within the project because it was not beneficial to us in how we were debugging our code. Another addition that we made is we made it so that the close buttons on the windows of the game actually function rather than just sitting there and not doing anything. They will now actually close the game if you click it. We fixed a couple of the issues related to faster hardware actually causing the game's time elapsed to run to 0, which would actually freeze the game. We fixed that by throttling speeds and making it so that the game will never actually run to 0. We fixed several crash issues related to base audio, and we dramatically altered Game Manager in order to account for the fact that we're now serving multiplayer. I'm actually going to pass it off to my group mate, Kyan, to talk more about how the multiplayer functions.
So in order to implement pretty much any of the behavior necessary, we realized immediately that there was going to have to be some dramatic shift in behavior of the program. So almost immediately in the main loop, we realized we're going to need a switch statement, and we started setting up the ability for the program to effectively run in different configurations. So this right here allows it to switch to the new multiplayer screen, which has all the controls and stuff necessary to facilitate multiplayer play. And in the main update and draw methods, such as right here, we have a switch statement which is able to evaluate which mode we're in, and we have several conditions that are able to get information about the current networking configuration in order to play the game properly. As of right now, the multiplayer has support for 2-player co-op. However, in theory, it could be extended to support any amount of players. And we've created a whole new package to support all of this networking stuff. So we have a class that wraps around a networking client, we have a networking server, and we have a whole bunch of helper classes that work together with them that make it easier to send data back and forth. The way we're doing it is we're using UDP sockets, and we're sending packets that have identifier bytes at the very front of them. It's more of a technicality, but the basic idea is that they have IDs associated with them so that we can determine what type of packet they are when we receive them. Now, as for the game itself, you'll notice immediately once we launch it, there's a new button here. This allows you to go to the new multiplayer screen. However, before we get to the actual multiplayer session, you can host a game locally by hitting the host game, and you can start a game without any other players. This is necessary in order to playtest, but it also shows off one of our other features, which was the multiple mode selections. So we only have 2 implemented thus far. We have this very rudimentary wave defense, more of a proof of concept, and if we look at this, it loads you in to this stage, and the way this works is that you're on a round-by-round basis. With each round, there will be an increasing amount of enemies that spawn. It's on an exponential curve, so the further you go, the harder it gets, and it gets much, much harder as you put more time into it. So as we can see, we're on the first round. There are going to be, I believe, 3 enemies, is what it comes out to. And they are randomly positioned in the stage. These enemies behave differently than the base enemies in the game, which normally do not come after you if they're off screen. These ones have special AI that makes them come after you, even if you're outside of range. Now, as you can see, the second we killed the last one, it automatically triggered the transition, and we are now moving to the next level, which is going to have more enemies. Speaking of which, this level transition animation took quite a lot of modification to the way the game's renderer actually works. In order to pull that off, we had to utilize the Graphics 2D API, which allowed us to manipulate some of the pixel data in the images directly. In order to get that transparency and that like really intense like red pulsing you're seeing, we had to multiply the color channels. So, as you can see, we have this mode, which is very bare bones, and there's not a whole lot going on right now, but it demonstrates the extensibility of our model, and you could, in theory, add any sort of game mode you want, with any sort of behavior you want, simply by appending to the current subset that we have. So we have a co-op mode, which is similar to the base game that you get when you launch it. However, it allows you to participate with another player. So I can have my groupmate Ian connect to me, and we'll get a notification once he does. Okay, so as you can see, my partner Ian has connected. We got a notification in the server log that he's here, and we can send things to him through the in-game chat. It's very basic, but it demonstrates principles of two-way communication over the network. So I can now hit start game, and this is going to pull us into the actual main game. And you can see there's another player, and he's able to control him fully. He's playing just like I am. And we can even interact with each other and bounce off of each other's heads. And the way that this operates is we basically have to synchronize information about our game states. So you can see in the console down here, there's a whole bunch of stuff that's appearing. That's information about his position. So what's happening is every time he moves his character, my game gets notified about it, and it correspondingly updates his position on my screen. And whenever I move, he will get the notification that I'm moving on his screen. As for the enemies and stuff, to get them synchronized, we had to create additional structures to contain information about enemy spawns and enemies getting taken out. The way we did that is with a dynamic packet system, where we were able to use the identifier at the front of the packet's data to determine what sort of behavior we should have when we receive it. You can also see this is one of the new enemies. This balloon will hone in on you, and if it gets too close, it will pick you up and try and drop you. It doesn't actually hurt you on contact, nor can you kill it. Its main purpose is actually in conjunction with other enemies that you'll see later on. So, you can see he's about to hit the heart, and we're going to go to the next stage. And now that we're on the next stage, you can proceed through as normal. You can also jump off of the other player's head, so you can actually use that to cross additional distance if you want. We haven't really designed the stages around it, but you, in theory, could design your level around this mechanic. So, this is one of the first enemies we've encountered that shoots projectiles. The way that this works is the projectiles are basically additional creatures. However, they've been modified a little bit in that they don't have the normal, like, physics and AI and stuff. They are instead given this hard-coded trajectory, which we calculate using some trig. However, other than that, they're pretty much the same as all other enemies. The main technical challenge behind getting this working was finding a way to effectively capture all the information to make both games sort of agree with what's going on, and also efficiently transmit the data in a way so that we could realistically convey this sort of information. In order to get it so that each creature, like the enemies, this boss, each other player, in order for us to update the positions correctly, we're employing a very common model when it comes to computer networking. We're using a client-server model. Now, I am hosting the game, which means that I am the server, so my computer is dictating everything that's happening in the game world, and his client is pretty much just looking into it, and his game is just updating based on what mine tells his to do. The only thing that he's actually sending back to me is notifications of when he kills enemies, and of course his position. So you can see when he bumps on the scorpion, it disappears.
So that just about wraps up the details of all the changes we made. So just to give you a brief rundown of the important changes that we made, we added a multiplayer system using host and client style connections by sending encoded packets with identifiers that will communicate information between both game states in order to keep them synchronized, such as how the player moves or whether an enemy is alive or dead. We added many, many new enemies with different functions, with each one having individual different functions. One enemy in particular actually does no damage and is a support enemy for other enemies that fire projectiles.
So that about concludes our presentation. We've spent a lot of time working on the individual systems and perfecting everything to get this into the state that it currently is. It turns out that testing is super important whenever you're doing anything involving networking, and we came across all sorts of weird bugs along the way, ranging from one player jumping causing the other to shoot off into space, to the wrong types of enemies spawning on the other person's machine. It was a lot of work, but we eventually sorted out all these bugs one by one, and along the way we learned a lot about debugging, working as a team, and designing reusable code, and overall this project was a great learning experience.